morning to everyone. So today I am back with the fifth video of Let's Chem. There has been a lot of irregularities in making the video, and I do agree this is because of the busy schedule that I am handling right now. And in the next coming month, that is mostly this month and onwards, and the videos are going to be more regular. There's a small concept that I want to discuss with all of you. Along with these chemistry videos, I have thought to start a subsection of this Let's Chem, that is Let's Talk, in which we'll be discussing the different problems, the different challenges that we face across life, and we'll try to solve those problems with the help of algorithms, which are very popular. Like, I think everyone who is related to the branch of science, or if you are very much interested in computer science or anything like that, you would be heard about algos. Algorithms are the basic solution of every problem. So so when I was in IT sector, I have drawn a lot of algos. This is not going to be a technical algo, but it is going to be a more of an algorithm which will help you to solve your issues related to studies and related to your life. It will help you to achieve your goal in a better way. So next video, that is I'm going to upload, will be the first video of Let's Talk. And please let me know how was that attempt. After uploading the video, please share me your feedback. Okay, so today the lecture that we are going to start with, we'll talk about a very important topic, which is called as intramolecular aldol. So intramolecular aldol is related to the chapter of aldehyde, ketones and carboxylic acids, and I hope you are aware about both the words. If I talk about intramolecular as well as aldol, so you know that aldol word has been derived from two important words, that is aldehyde plus alcohol. So corresponding to aldol, there is something called as ketol, but we do not prefer that name. So actually it should be called as aldol and ketol, but we as a whole we call it as aldol only. Okay, and intramolecular, I hope you are aware about the concept. Whenever intra word comes, it means what, guys? Within the molecule. So you would have heard this word at many places, including H bonding, inter and intramolecular. Intra means what? Within the molecule. So today we'll discuss about the shortcut methods to perform intramolecular aldol condensation, and then we'll see that there are two different tricks that I would be sharing with you today. Whichever you like, you can prefer that, and we'll be seeing some very important mechanisms also. Okay guys, so I think it's all set, so let's start. So I'll give you first of all a very basic definition. Okay, so we are going to let's start with an example. Okay, then I'll tell you some basic techniques and ideas. Okay, so as you can see, I'm drawing one molecule in front of you. 1, 2, 3, 4, 5, 6, 7. Okay guys, so I hope that all of you who are watching this video are aware about the basic criteria and requirements which are required for performing of an aldol condensation. what is the important factors and reagents which are required, and what are the basic conditions which are required for aldol condensation. I hope you all are aware about. Still, if you are not, I will recapitulate those things in the as the video progresses ahead. Okay, so this is a straight chain carbonyl compound, in which I am now going to, let me make clear it a bit by writing H here, so that you can understand whether it's a ketone or an aldehyde group, right? So what I'm going to do is, there is a different type of numbering that I would be following here, guys, and I would request you all to follow this numbering if you are following this technique that I'm following, that I am actually referring here. So here we'll start with the carbon, we'll call it as carbon number 1. Here this I will call it as carbon number 2. This will be called as carbon number 3, and this will be called as carbon number 4 as well as carbon number 5. So why did I call this as carbon number 1 and 2? Because this is the if this is the carbonyl carbon, this carbon is called as my alpha carbon, and I am presuming that this alpha carbon will be the one which will be attacking that another carbonyl carbon, which I have taken as the third carbon, and fourth and fifth are lying as an intermediate in between. Okay, fourth and fifth are lying as an intermediate in between. If you want, we can increase the chain. Okay, so let me just increase this chain a bit, so that this can be formed as a form of a ring. Even now we can make it as a ring, but just a minute. Okay, so what we'll do is, we'll increase the length a bit. I think, yes, now it looks proper, I guess. So yes, this is 5, this is 6, this is 7, this is 1, and this is 2. So everything remains the same. This is still my alpha carbon. This alpha carbon is no more alpha. This has become my alpha carbon now. Now this is my alpha carbon. I hope this numbering is clear to everyone. So I took this carbon as first, second, third, and whatever is there in between, I just gave it a random number 4, 5, 6, 7. You can go it in any other way. So if you are trying for a reverse approach, where if this is the attacking alpha carbon, even you know that this is also an alpha carbon. So here the definition of an alpha carbon is what, case? So alpha carbon is the carbon which is adjacent to a carbonyl carbon, and only all those alpha carbons can participate here in the attack. Like basically the attacking alpha carbon should have alpha hydrogen, as well as the carbon which has been attacked. So this is, I think, very much clear to everyone about aldol condensation, right? So both the alpha carbons I have marked. Okay, as you see the mechanism, you'll understand the insights of it. Right now we are just showing you the shortcut method. So guys, what will happen here is, I'm just drawing the final product. So we'll see as an explanatory part also. What will happen is, okay, so what carbon are we going to attach here is that second carbon is going to get attached to the third carbon. So finally what you are going to get will look something like this. You'll get a ring like this. So sorry for this. So you'll get your first carbon here, second, third, fourth, fifth, sixth, and seventh. So guys, have you seen what has happened actually in the final the result? What exactly has happened is, the carbonyl carbon that was attacked, that is the third number carbon, and converted to OH, alcohol has come here, and there's a retention between the first carbon carb, and there has been a ring formation between the second and the third carbon in the straight chain, and it has given a result to the final structure. This will see as a mechanism, so don't worry, stay tuned. So I'll show you. Okay, and this formation, this formation is there at which is happening at a low temperature. Okay, this is not the condensed product, this is something which is happening at a low temperature. So further, when you heat this, guys, when you heat this, so I'm writing a delta here, what happens is there's an elimination of water molecule. Okay, water molecule gets eliminated. So which from where it gets eliminated, that also I'll show you. Okay, so this OH and this H gets eliminated, so I'm writing here minus H2O, and finally what do we get, guys? Look something like this. So this is your 1, 2, 3, 4, 5, 6, 7, and here comes a pi bond. Now this is called the condensed product, or it is the aldol condensation. So this is at what temperature, guys? This product is there at high temperature. And this is the one which we got at low temperature. So I think both the products are okay with everyone. Okay, so see, this video that I'm making is considering that you know the basics of Aldol. Okay, if you don't know the basics of Aldol, do please read that first and come, because it would not be very much promising for you if you are not very much aware about the insights of Aldol condensation. So basically this video is for those students, those who have read this chapter before. Okay, now coming to the next part, I'll just recapitulate the method of numbering. How have I done? So I'll just present here the method of numbering. If this video goes big, guys, I'll continue this in the next video also. We'll go very slowly so that step by step things become clear to you, and the method of numbering is very actually very important. So first method of numbering says that okay, the carbonyl carbon, let's write down, the carbonyl carbon which does attack, or the carbonyl carbon from which side attack happens, actually you can write like that, okay, is C1, carbon number 1. So as you can see that our attack is happening from this side, from the right hand side. So that is this carbon that I'm talking about right now. Okay, so this is my this is the carbon which is concerned for us. Okay, now so second point that we'll be writing is the alpha carbon, being considered is C2. Okay, and third point that we'll write is the carbon being attacked, the carbonyl carbon being attacked is what, guys? C3. Okay, so this method of numbering will be like a very important for us to understand this technique. And whenever we are writing this, guys, so what I will do is, or what as a practice you can do is, you can capture that area which is going to form a ring. Like for example, if I see here, this area was my area of concern, exactly from where the ring formation happened. Actually, if you can check, this area has went for what, guys? Ring formation. And see, this is the reason why I'm going very slowly, so that you can actually cross check whatever I'm saying is correct or not. So if you can see how many members are there in the ring, 1 2 3 4 5 6 membered ring we have. Okay guys, all good as of now. I hope you're understanding the way of my explanation. If there are any such issues that you are finding a problem in, you can just comment it, and if possible I can make one more video on that. But as of now, I think those who would have read Aldol basics, they would be okay with this. Okay, so let me draw the final product again that we have got, not the condensed one, actually the low temperature one. So mostly we'll be making the low temperature product until unless it is mentioned high temperature or anything such as heat form of data. So if I draw that product here once again, okay, so I will draw a ring, actually 6 membered ring, and then I'll draw something like this, and here will be H, and then I'll start numbering it 1 2 3 4 5 6 7. Now guys, what I will do is I'll do retro Aldol, means I'm going to reverse back, and this is a separate topic that I will be taking right now. What is the basic technique of doing retro Aldol is break the bond between 2 and 3. Break the bond between 2 and 3, gone. Okay, convert the OH part of third carbon to carbonyl carbon. Okay, carbonyl carbon means C double bond O, and what you have to do is you have to give the hydrogen atom to the second carbon. So if I do that part, what do I get here? I get a double bond oxygen here. The ring is broken now. It still looks like this. There is no bond between the second and third, and what has come now is we have got a hydrogen atom here. Okay, I hope this is fine with everyone. Numbering, if I do, it's like 1 2, this is 3, this is 4 5 6 and 7. Okay, so now comes an important part. We are going to do Aldol reaction here, intramolecular Aldol reaction here, followed by condensation for sure, and we are going to study the mechanism behind it. So let's put the heading. Okay, we are not going to study the mechanism of this reaction, rather we are going to study the mechanism of this reaction. This mechanism we are going to study. What is the mechanism of intramolecular? What is the mechanism of intramolecular Aldol reaction? So guys, let's put this heading, mechanism of intramolecular Aldol reaction. So I'm going to take my starting product and the starting reactant, and I'm going to proceed ahead. Let's see how. So here also I'll draw one H carbonyl it is. Okay, so let us first draw like this, or you can draw it in a form of a straight line also, that is not a problem. Okay guys, I hope you are aware about that concept also, H. Okay, and I'll draw one H here, and just I'll number it 1 2 3 4 5 6 7. It's good to go. So Okay, so first step is a very important step. Let's see some arrows I would be drawing here. Let's try to focus on the arrows. How are they going to move? Okay, so always remember that this reaction you're doing in the presence of dilute NaOH. So there is always presence of OH minus ion in the solution. So the first step actually goes like this. This bond shifts like this. Okay, and this OH minus takes away this hydrogen atom. Okay, now the hydrogen atom which is being taken off is from the alpha carbon. It's not from the carbonyl carbon. Please remember that. So if we tend to do these two steps simultaneously, guys, and if you can check what are you going to get here next. Okay, so what are you going to get next would look something like this. What I'm drawing here is, okay, let's see whether we are able to get this or not. Okay, so now this is going to come here. Okay, and what has come here is a pi bond, and if I number this again, if I get 1 2 3 4 5 6 and 7, yes, looks good, I guess. Yes, so exactly this is what is going to come next. Okay guys, this is the 7 number carbon, and if you are aware about this ion, it's called enolate ion. What is this called as, guys? This is called as enolate ion. And am I missing something? Yes, I'm missing something. I'm missing the carbonyl carbon on the third carbon. Sounds good. Okay, next what is going to happen is this is going to not remain as it is. It's going to rearrange, because you know that it's not very stable because of the charge. We have to make it in the form of a neutral molecule. So next bond breaking is going to be how actually. Let's check. So what happens is this negative charge, sorry for this. This negative charge goes here. Okay, this pi bond, this okay, this negative charge goes here, then this pi bond moves here, and this pi bond moves this side. Okay guys, so what are we going to get here is, now see that this pi bond on the second carbon is approaching that of the third carbon. So what are we going to get, guys? Any guesses? We are going to get back our ring. Yes, we are going to get back our ring. That's true. We are going to get back our ring. Okay, and it's going to look something like this. The double bond again retained back, and here we have a minus sign. Okay, so if I number this again, how will it look like? It's look like 1 2 3 4 5 6 7. Sounds good. Yes. So next what is going to happen is, as you know, it's a dilute NaOH. So along with OH minus ion, there would be a presence of water molecule for sure. Okay, so this is going to be there, and exactly what is going to happen is a bond will break like this, and this will be taken away, take away the H plus ion, guys. So next what are we going to do is, actually next what is going to happen is, next diagram I am drawing here, I am taking it very slowly so that you can understand step by step. Okay, I could have done it in a smaller way or in a more faster way, but that would not be a great help for you guys. Now this is the exact structure that we were searching for. 1 2 3 4 5 6 7. Yes, now we are going to heat this. We are going to write delta. So I hope you know what is going to happen next here is called as dehydration. Okay guys, so dehydration is going to happen here. How it is going to happen, that also you should have a check. Okay, so what is actually present here, if you check, there is a hydrogen atom here. Okay, and fine, this is called as, let me once clarify you that considering this a carbonyl carbon, okay, this is called as my alpha position and this is called as my beta position. So the reaction that is going to happen here is alpha beta elimination. I hope many of you could recall this from your class 11th as well as class 12th. Anyhow, dehydration, you know that you have read in the alcohol chapter that dehydration is an example of alpha beta elimination, right? So ultimately what is going to happen is the OH minus ion is going to take away this H from here. So guys, this bond is gonna break and this also is going to get out of this. Okay, so finally, as I told you, what are you going to get once you heat this, which is a continuation here that I'm writing actually. Okay, so finally what are you going to get, guys? You are going to get your alpha beta unsaturated compound, and that is all aldol condensation is all about. And I hope you are aware about that. Yes, you are aware about it. 1 2 3 4 5 6 7. This is our final product that you have got. I would leave a question for you guys to be answered in the comment section. What is the IUPAC name of this compound? Let me know in the comment section. What is the IUPAC name of this compound? Okay. So, fine. So now we will have one question here. Okay, let me show you one question. So it's a very interesting and good question, guys. Okay, so we'll see both the conditions. Okay, so I'll give you some compound here. Okay, 9 carbon atoms. Let's draw. 1 2 3 4 5 6 7 8 9. Wow, exactly 9. Okay, so we are going to put one carbonyl carbon here and we are going to put a carbonyl carbon here. Okay, and we are going to do a reaction with dilute NaOH followed by delta. So finally what product we need is the aldol condensation product. So guys, I would request you to do the same way that I've done without the mechanism, if you can do, by giving a pause to this video, if you can try. Okay, I'm pretty sure you would be able to do this, but before that let me give you a small hint here. There are 2 possible cases which can happen here. Okay, there are the 2 possible cases which can happen here is what? Let me consider that this carbonyl is going to attack. So this and this are going to be my 2 points from where the attack can happen. Means what I'm saying is this is also alpha carbon and this is also alpha carbon. So considering that this will attack this carbonyl, brings out a case for me, which is case 1. And considering that this attacks here is a case 2 for me. Okay, many of you would be thinking that why I'm not taking a case where this carbon is attacking this carbon. There also can be 2 cases, right? This one and this one, considering them as alpha. Okay, so just think about it. Okay, in the course of time you'll come to know why exactly that is not happening, and there should be a lot of questions in your mind right now. I'm ready to answer all of them. If you can let me know through what are your all doubts in the comment section. Okay, so let's see these 2 cases, guys. What exactly is going to happen here? Okay, so first I'll show you case 1 and then we'll move to the case 2. I think seeing the length of the video that we have to make another video on it, because there are much left in this, and yeah, it's a big topic. So I would cut short after this question. What we'll do is we'll upload another video on the same topic as a continuation. So first I'll show you the case 1. What is case 1? Case 1 is, I hope you can see what attack is happening in case 1. So before that, guys, the most important part is the numbering part. That will do for the case 1. So first I'll draw the compound again. So 1 2 3 4 5 6 7 8 9 this one and this one. Okay, so as I told you, can you tell me which is going to be the first carbon? Any guesses, any ideas? Yes, correct. This is going to be by first carbon, this is going to be by second carbon, this is going to be by third carbon. In between I have a carbon, so I'll call it as 4. Now can you see there are some extra lengths present on the right hand side as another left hand side? For my own simplicity, what I'm doing is I'm just numbering them as randomly C, D, E, 4, 5, 6, anything you can take, and here I'm numbering them as A and B. It's again for my simplicity that I'm doing this, guys. So what is going to happen at low temperature? I'll show you the case 1 products. You can try this with mechanism. It's not working fine, then you let me know. Okay, so what is going to happen at low temperature? That the second carbon, that is the alpha carbon, is going to attack the third one. So can you imagine what is going to happen, guys? Now yes, ring formation will be there. The third carbon will get attached to the second carbon. Okay, in between there is a fourth carbon, third carbon is here, and this third carbon will be attached to on something like this. Second carbon afterwards will go out as nothing has happened. So we'll get something like this. Yes, this is our final product. No, not at all. This is our final product at low temperature. Yes, it is correct. So this is 1 2, then it is C, D, E, and this I'll call as A and B. I think it would have not taken much time for you to have drawn this. If it is taking time, that is not a big deal, guys. We can just work it out. High temperature, what is going to happen? Tell me fast. High temperature, what is going to happen? Yes, correct. This H and this OH is going to say tata bye bye, and we are going to have elimination here. What type of elimination, guys? Yes, exactly, alpha beta elimination. And what are we going to get? Will look something like this. Exactly. Do you agree? This is 1, this is 2, this is 3, this is 4, this is A, this is B, this is C, this is D, and this is C. Okay, now see, in high temperature, if I get into the stereochemistry part actually, and if you check the hybridization of the carbon which are here, like let's check about this ring formation part, or how okay it is to form this ring, and whether the ring at low temperature is more strained or the ring at high temperature is more strained. So if you see guys this angle, okay, if you talk about the hybridization of the second carbon atom, it is sp2 hybridized, and if you talk about this also sp2 hybridized. So theta is going to be here what, 60 degree. So there will be a condition of angle strain here. There will be a condition of angle strain at high temperature. Okay, angle strain is there at low temperature as well, but because of the hybridization change, as you can see there and here, there is a change in the hybridization, so that is going to be a calculative factor. Now if we see case 2, okay, now you are going to tell me that which case is going to be the more favorable one considering the stereochemistry part. If you can, case 2, what I am going to do is, in case 2 guys, okay, I'm going to draw my original structure again. Case 2, I'm going to draw the original structure again. Okay, so 1 2 3 4 5 6 7 8 9, and yes, there is the carbonyl carbon, and 1 2 3, here is the carbonyl carbon. Numbering, if I'm not wrong, this is 1 2 3 4 in between, AB, and yes, now this is not 2, correct. Everyone, those who are saying that this is not 2 this time, because alpha that I am taking is from this side, so this becomes my 2, this is 4 and 5, and this is what guys, this is again, let's say my AB. If I take this side also, AB will not look good, so let me take this and make it as CD, doesn't matter. Okay, now what is the attack going to happen here? This second carbon, that is the alpha carbon, is going to attack the third carbon. So guys, can you imagine the ring 1 2 3 4 5? So the ring is going to look like this. What is going to happen at high temperature and low temperature? Can anyone tell me? First, let's see the condition of low temperature. So at low temperature, what is going to happen? We are going to get a 5-membered ring. Okay, 5-membered ring like this. Yes, so what we are going to get is a 5-membered ring here with a double bond O. This is my first carbon. Then let's come to the second carbon. Now second carbon is attached with a tail like this, which is my B and A that I'm going to mention later on. And third carbon guys, as you know, what will come here is OH, and again it's having a tail like this. So if I number it, it will be 1 2 3 4 5, with number 3 getting CD and number 2 getting AB. If I am not wrong, this is the correct structure. Now what will happen at high temperature? Simply, when I am going to give a condensation product, when you are going to heat it, you'll for sure get a condensation product guys. So I hope you know what is going to happen now. Okay, any guesses? This hydrogen and this OH is going to be eliminated out, and what are you going to get is going to look something like this. So guys, this tail is going to be still there, this tail will be there, first carbon remains unaffected, and there is going to be a bond like this. So what numbers are we going to write here? This is CD, this is your AB, this is your first, this is your second, third, fourth and fifth. This is at high temperature. Okay, now can anyone just think and tell me which case is more favorable? Obviously, if you would have studied a bit about angle strain and strain that is comes due to the ring formation, you will agree if I say you that case 2 is going to be a favorable product. As we can see that in case 2 we are making a 5-membered ring, as compared to case 1 we are making a 3-membered ring. Okay, so 3-membered ring and 5-membered ring, for sure 5-membered ring is more favored over 3-membered ring. That is the actual criteria. So again, yeah, I would like you to tell me the IUPAC name of whatever products IUPAC name I have missed. Okay, you can take a picture of them, or you can redraw it again, like I have asked you the IUPAC name of this. So in this also, guys, if you can tell me the IUPAC name of, let's say I will give you all the numbers, let's say we call it as number 1. So tell me the IUPAC name of number 1. Similarly, tell me the IUPAC name of all the products if I am asking you for. So in case 1, if you can tell me the IUPAC name of number 2, what is the IUPAC name of number 3, and similarly 5 IUPAC names will come. What is an IUPAC name of number 4 and IUPAC name of number 5? So do some chemistry and let me know in the comment box what are the IUPAC names. Okay, good enough. So guys, there are 2 topics left. One is intramolecular aldol condensation, and another is a mechanism approach to solve such problems where numbering is not very much important. What do you have to have the mechanism approach to solve this? Okay, and one more question I have asked you, that why is the reverse attack not happening here in this case? I asked you, right, the question that I gave you. So just think about it, and I'm pretty sure that you'll get the answer. If you're not getting the answer, I'll tell you in the next video why is that attack not as favorable as the one that I'm showing you. Means 2 more cases would have been made here actually, like this, if attack would have happened. So if I can show you like this with using another pen. Okay, so this could have attacked here, and this could have attacked here. Okay, but actually I'm not going for that right now, because I want you to think and then tell me that particular answer. Okay guys, so as the length is increasing, I would feel I feel that you guys would find it a bit boring. So what I'm going to do is I'm going to just stop this video right now. Okay, and I would ask you to go through it once, twice, thrice, and then come with the doubts in the next video in your comment section, as well as the continuation of this video will be done in the next this video will be continued again. I mostly tomorrow I'll upload the new video which will be a continuation of this video, so that you can recapitulate all the concepts in one go. And one more request guys, my YouTube channel, as I'll show you. So yes, this is my YouTube channel. If you can see, I have uploaded some videos already on this YouTube channel, and I will be uploading some more videos. There are going to be some changes which are going to come in future. I might start taking classes on board. If you guys are feeling like taking it on pen paper mode is not that good, but then all it takes is the visibility problems and all that comes, which I don't feel here it is present. One more thing, what I'm going to do is from this lecture onwards, I'm going to upload the PDF of this file in the Google Drive, whose link will be attached in the comment section or either in the description of the video. The same link will be attached in the Google Drive. Link will be attached on my Instagram page. So if you are okay, please do like, subscribe, and also I'll just show you the Instagram page. So this is the page that I am having on Instagram. Okay, everyone can like this page and for more updates. So fine, so I think that's for enough for today. We had a pretty good section guys, and yes, I would be looking forward for all of you in the next video. Stay tuned, stay happy, stay blessed. Thanks for watching this video. Have a great day ahead. Thank you. Bye bye.